Hello everyone, welcome to the second of Huawei HCIP OpenELDR certification course. In the previous section, we introduced the clusters and common concepts in clusters. Now, let's learn some common cluster deployment tools. The first one is LVS.
This section describes common cluster deployment tools. Let's start with LVS. LVS is the best load balancing tool. It is usually deployed at the front end of the service cluster and close to the user side. When a user accesses a service, the service is forwarded by the LVS. The backend of the LVS may be a Layer 7 load balancer or directly connect to the real cluster. There are several basic concepts in LVS. First, VIP. As we have mentioned earlier, users access service through VIP. The second is DIP, which is configured on the LVS node. When a user connects to a backend service, the request from the user passes through the VIP and then forwarded by the DIP to the backend service cluster. The last one is RIP, which is called Real IP. It is configured on a real server cluster host, and the RIP must be able to communicate with the DIP. The LVS can only perform load balancing scheduling, which is easy to cause single points of failure. In actual scenario, LVS works with KeepAlive to form an LVS HA cluster to ensure service stability. Actually, the LVS consists of two parts. The first part is IPVS, which is short for IP Virtual Server. It has been included in the Linux kernel. Therefore, it does not need to be installed. You only need to ensure that it is loaded after installing Linux. We can use the lsmod command to see if the module is loaded. The second part is IPVS admin, which is an LVS configuration tool and runs in user mode. Administrators can add, delete, query, and modify LVS rules through IPVS admin. IPVS is not a mandatory component of LVS. If KeepAlive is used to configure LVS rules, IPVS admin does not need to be installed. The IPVS admin command format is as follows, which will be used in practice later. And some of these commands are very useful. For example, the first one, the IPVS admin -C command is used to quickly clear all rows. And to prevent accidental root or to facilitate backup, we can use the IPVS admin -SN to etc sysconfig and IPVS admin command to save the current LVS rules to a configuration file. This allows you to restore the rules from the file when you need. And also, if the rules have been saved in the configuration file, you can load the rules by run the IPVS admin -R from sysconfig IPVS admin. Use this command, it will be very useful in restarting the machine or if there is a problem. And the final one, after all rules are configured, you can run the IPVS admin -LN command to view all LVS rules. After the rules are configured using KeepAlive, you can also run this command to check whether the configuration takes effect. Okay, now let's look at the 3 working modes and 12 scheduling algorithms of LVS. The 3 working modes include NAT, DR, and Terminal. The NAT and DR modes are commonly especially the DR mode. Therefore, only the two modes are included in practice part. Besides this, the LVS supports 12 algorithms, including static algorithms and dynamic algorithms. And the FO and OVF algorithms are newly added in LVS 4.15 and are rarely used. Therefore, they are not described separately in the following slides. So the following section describes these working modes and scheduling algorithms one by one. First, let's look at the NAT mode. In this mode, the destination address and destination port in the request package are forwarded to the addresses and ports of different service hosts according to the configuration and algorithm. And now, from the case, we assume that the user IP is 192.168.1.10. The LVS DIP is 10 segment .12 and service port is 80. And the row server RSIP is 172 segment and 2.100. Service port is 8443. Okay, let's take a look at the specific access process. First step, the users send the request to the LVS. The source address is 192.168.1.10, that is the user IP, and the destination address is the LVS VIP. The destination port is 80. And after receiving the request, the LVS schedules the request and rewrites the data packet. The source address remains unchanged, and the destination address is changed to 172 segment and 2.100, that is the RSIP, and the destination port is changed to 8443. After receiving the request, the RS processes the request and changes the source address to 172 segment 2.100, the RSIP, destination address to 192 segment 1.10, the user IP, and the source port changed to 8443 in the response packet. Okay, so after receiving the response packet, the LVS modifies the packet by changing the source address to its VIP address and the source port to port 80, destination address to the user IP, and destination port to the port that sends the request. And then, final step, the LVS sends a modified packet to the user. So from this case, we can see in NAT mode, all request and response packets need to pass through the LVS node. If the traffic is heavy, the LVS node is bottleneck. Therefore, NAT mode is less used in production scenario. Okay, next, let's look at the configuration example of NAT mode. The following is an example of how to configure LVS NAT mode, and we will demonstrate each step. The first step is to enable the address forwarding function of the LVS. We open the syscontrol.conf file in the etc syscontrol.conf, and then we find the line NAT IP version 4.ip forward equals 0 and change the value of the NAT IP version 4 IP forward to 1, indicating that the IP forwarding is allowed. And you can also use the seed command to change the value. The modification is now complete. Next, let's apply the changes by running the syscontrol-p command, which immediately applies the new settings in syscontrol.conf, cause the system to start allowing the IP forwarding. The third step, we need to check the setting and make sure that the value of net IP version 4 IP forward is correct. You can run the grep command. After running this command, you can see that the result net IP version 4 IP forward equal 1, which indicates that the IP forwarding is enabled. Then we can run the cur at VIP command on the current server to check whether the current VIP can be forwarded without configuration. And you can see here that the connection failed. And next, we can cur the IP address of the backend server, RS1 and RS2. Both of them can output the IP address, indicating that the backend server is normal. So now let's perform the configuration of the VIP net mode. And first, we add a cluster. First step, we create a virtual service, run the ipvs-admin-A-T command to create a virtual service, specifying the VIP and port number to 80, and set the scheduling algorithm to RR, round robin. After the configuration is complete, the virtual service cannot be forwarded. And so we need to add the backend RS. First, we add the first backend server, the real server. Add RS1 in the subnet to the virtual service. We set the weight to 1 and use the net mode. So in this example, we can use IPVS admin-A to add a backend server, IP address, -R to specify the IP address and port number of the real server, and -M to use the net mode. Next, we add the second real server, the RS2 of subnet 2, to the virtual service. Also, we set the weight to 1 and use the net mode. After the LVS is added, we can run the IPVS admin-ln command to view the current LVS configuration. The command output indicates that a load balancing cluster in LVS net mode is successfully configured, and the VIP is 192.168.1.10, port 80. The scheduling algorithm is round robin, and the two real servers are 1.2 and 1.3. So to sum up, we have completed the basic configuration of LVS net mode, including enable address forwarding, create virtual service, add real servers, and verify the configuration. And the clients now have the VIP access to the service. So we can directly cur the VIP. And then you can see that the forwarding is complete. And let's run again. You can see that different servers are executing the task, performed the third time. And we can see that the operation returns Nginx 2. This is the round-robin algorithm. So this is a configuration demonstration of the LVS net mode.
This section, we describe the common operations and working modes of LVS, and we demonstrate the net working mode of LVS through the actual case. In the next session, we will introduce other LVS working modes and common LVS scheduling algorithm. Thanks for watching.